Hello everyone, today we solve the mathematics question paper for the lecturer for non-government aided college of Odisha. Let us go to the first question. The first question is from the abstract algebra topic. It is from the group theory. Okay. In the first question, it is given that a non-empty subset H of a group G, means H is a subset, H is a group. What are the necessary property that H should be a subgroup of G? One property is given that when A belongs to H and B belongs to H, implies that A dot B belongs to H, means it is the closure property is given. But we know that for a subset to be a subgroup, it should fulfill two properties. One is the closure property and second one is the inverse property. Okay. But a subset, when a subset becomes a subgroup, it also itself a group. Means other two properties, one is the associative properties and otherwise the existence of the identity element. These two properties are satisfied vacuously, means obviously satisfied. If a closure property and the inverse property is in the subgroup, then it implies that existence of identity element B is also in the subgroup, because closure when A belongs to H implies A inverse also belongs to H by due to the inverse element, existence of the inverse element, and we know that A belongs to H, A inverse belongs to H by the closure property A dot A inverse belongs to H. From this you can conclude that A dot E is H, A dot A inverse is E, identity element, so E also belongs to H. So we only need to verify that whether the closure property and the inverse property are in the subgroup or not. Okay. But the closure property is given, so we need to verify whether only the inverse property. But first property is the A dot B equal to B dot A. This is the commutative property. This is not the inverse property, so it is not true. And the second one is the associative property. This is also not true. And third one is the existence of the identity element. This is also not true. And the fourth one is the existence of the inverse element. For the every A belongs to H, A inverse belongs to H. This one is our required property. So the required answer is D. Okay. Let us move to the second question. In this question, a subgroup N of a group is G is a normal subgroup of G if and only if. Okay, normal subgroup. What is the definition of normal subgroup? A subgroup is a normal subgroup when it satisfies that G and G inverse equal to N for all G belongs to G group. Okay. From this we can conclude that Gn equal to Ng. What this implies? This implies that every left coset is also a right coset. This is the left coset, this is the right coset. So let us verify the options. It is only left coset, it is also not true. It is only right coset, it is also not true. Every left coset of N in G is a right coset of N in G. This one is the required answer. And this is option D is not true, because Gn not equal to Ng it is given, but we are getting that Gn equal to Ng. So option D is also false. Okay, the right answer is the option C. Let us move to the third question. In the third question is from the homomorphism, group homomorphism. Group homomorphism is a function from phi mapping from G to G var. But this question is not concrete. In this question, it should mention that G is group under what? Under addition or multiplication. Two things are there, na? G bar is also has option also addition or for the multiplication. If they both G and G bar are the if G is a group for under addition, under G is from this option we can it is clear that G is a group under multiplication, because everywhere AB option A, here also AB is written, here also AB and here also AB. From these options, so we can judge that G is a group under multiplication. Okay. So we can apply the definition of homomorphism phi of AB equal to phi of A dot phi of B. But here one thing is in if G bar is a group under addition, then the option A would be true. Okay, but from the formal definition which is written in the book, that phi of A dot B equal to phi of A dot phi of B, then the option C is the correct answer. But this question is not clear. Okay, this question is not clear because they are not mentioning which operations is in G and which operation is in G bar. Okay, but from the point of view of the book, the answer is the C. Okay, let us move to the fourth. This question is asked from the isomorphism. Isomorphism, we know that it is a homomorphism plus it is also satisfy one-to-one property. So on-to property is not true, into property is not true, phi is 1 1, this is the required answer. Phi may be many 1, this is not true. Okay, this is a very simple question. Let us move to the fifth question. A field is a division ring. Division ring, what is division ring? It is a ring which every non-zero element has also inverse. Okay, this implies that field is a division ring because field, what is field? Field is a group under addition. It is group. Okay, and multiplication also it is a group, means every non-zero element has also multiplicative inverse. Okay, and it also satisfies the distributive property. Total 10 properties are there. Distributive. Okay, it is a commutative group under addition, commutative group under multiplication, except the zero element. It has 5 property, and another property is the distributive property. So field is also a division ring. Division ring means it is a ring which has every non-zero element has multiplicative inverse. Okay, it is also a commutative ring. Okay, this one is also true. And a commutative division ring. Commutative division ring means it is a ring which is also means both A and B options are included in the C answer. Till now C is the perfect answer because it includes the commutative ring. It also a division ring. Both A and B are included C. And integral domain. What is integral domain? If every non-zero element has inverse and the and the product of two non-zero elements gives non-zero. Okay, this is the integral domain. But a commutative ring implies also it is also integral domain, means every option A, option B and option D are included in option C. So option C is the more concrete answer. Both are a field is also integral domain, a field is also a division ring, a field is also a commutative ring. No doubt a field is a division ring, no doubt a field is a commutative ring, no doubt it is a integral domain. But the all the three things are included in the option C, means option C also implies that a commutative division ring is also a field. Both are equivalent statements. So option C is the perfect answer. Okay, let us move to the question number 6. Okay, in this question, phi is a homomorphism from a ring R into the ring R dash. Phi is a homomorphism. Phi is a ring homomorphism from the ring R to R dash. Okay, and in the ring there are two operations. One is the addition, another is the multiplication, and the additive inverse is represented by the minus sign and the multiplicative inverse is represented by the power minus 1. Okay, but in the options in the left hand side, the minus A represents the additive inverse of A. Okay, but from the ring homomorphism is also a group homomorphism under addition. So from the group homomorphism or ring homomorphism, we know that phi of minus A equal to minus of phi A. Okay, this is the property. So which option is true? First option is false, second one is the true, and third one is not true because this that whole to the power minus 1 inverse is the from the multiplicative inverse, but not this because minus A represent the additive inverse. This is not true and this is also not true. Okay, option B is the right answer. Okay, let us move to the question number 7. Question number 7 is given that U is an ideal of the ring R. here we can compare one thing, that ideal and the ring. Like in group, there is normal subgroup. In group there is normal subgroup N and the group G. In the similarly in ring there is ideal and the ring R. Okay. We have to know why normal subgroup is necessary. One beautiful thing for the normal subgroup is that G by N quotient group. G by N is the quotient group. This is all is a group. Similarly, to define the quotient in ring, ideal comes. Okay, then R by U is also a ring. It is a celebrated theorem in the ring theory. There is a theorem that if U is an ideal, then R by U is a quotient ring, means it is a ring. So which option is true? Option A is false because R plus U is given that, and option B is the correct answer because R by U is a ring, and option C is also false, option D is also false. Okay, let us move to the question number 8. Question number 8 is a very easy question because it is asking about the GCD of 12 and 13. This is a question from like question class 5th or 6th, like that. Okay, for the convenience I have also calculated what is the GCD of 12 comma 13. Then we calculate if we take 6 2, okay, and 5. Okay, there is no common factor. Highest common factor is the 6. Okay, so option C is true in question number 8. Let us move to the question number 9. In question number 9, it is given that for what value of p, 3p plus 1 is a perfect square. Actually, in this question also, this question is also not clear or complete because here it is not mentioned that p is a prime number. But usually whenever we take 3p plus 1 from these type of questions comes from the number theory point of view, you usually consider that by default p is a prime number. Okay, but if p is any number, then it can be something else, but usually we assume that p is a prime number. Okay, so let us move to the answer. Okay, in question number 9, what is given that 3p plus 1, we have to calculate 3p plus 1 is a perfect square, means suppose that 3p plus 1 is n square. Perfect square means for some values of for some n belongs to natural number. Okay, and here p is a prime number. Okay, then what can we do, that we can calculate 3p equal to n square minus 1, and it gives 3p equal to n plus 1 into n minus 1. Okay, from this what we can conclude, that here 3 is a prime number and p is also prime number. So n plus 1 has two options only. It can be equal to 3 or it can equal to p. Similarly, n minus 1 has also two options. It can be either equal to 3 or equal to p. Okay, let us check the options. If we look at that, suppose that n plus 1 equal to 3. If n plus 1 equal to 3, then what will happen? It gives that n equal to 2. N equal to 2 and then n minus 1 will be equal to what? 2 minus 1, it is equal to 1. So n minus cannot be 1, n minus 1 equal to 1, which cannot be equal to 3 or cannot be equal to p, because 3 is greater than 1 and p is also a prime number which is also greater than 1. So we cannot take n plus 1 equal to 3. Okay, so we can only take n plus 1 equal to p and n minus 1 equal to 3. If we take n minus 1 equal to 3, then we will get n equal to 4. If we take n equal to 4, then what will be equal to p? P equal to 4, n plus 1. P equal to what is p equal to? P equal to n plus 1, which is equal to 4 plus 1 equal to 5. So 5 is the correct answer. Therefore 5 is the correct answer. If we put p equal to 5, it gives 3 into 5, 3, it gives what? It gives 3 into 5 plus 1 equal to 15 plus 1, which is equal to 16, which is a perfect square, 4 square. Okay, so 5 is the correct answer. So option D is the true. Let us move to the question number 10. In question 10, it is given that the GCD of a, 30 equal to 1. We have to check that a to the power 4 plus 59 is divisible by 60 or 61 or 62 or 63. We have to check this. Let us check it. First of all, it is given that a, 30, GCD of a, 30 is given that 1. This implies that GCD of a, 3 is also 1, and GCD of a, 5 is also 1. This implies that a does not divide not a 3 does not divide a, and 5 also does not divide a. Okay, this is given. From this we conclude that a either congruence to plus minus 1 mod 3, okay, or a congruence to plus minus 1 mod 5, or a congruence to plus minus 2 mod 4 mod 5, sorry, okay, plus minus mod 5, because when 3 does not divides a, the remainder should be either 1 or 2. For the mod 3, 2 can be written as minus 1, but when 5 does not divides a, then the possible remainders are 1, 2, 3, 4, because 0 cannot be remainder, because 0, if the 0 would be the remainder, then 5 divides a, so 0 cannot be the remainder, and so there are 4 possible remainders. One is 1 plus 1 or plus 2, other is the plus 2 and plus 3. Plus 2 and plus 3 can be written as minus 1 and minus 2. Okay, so we have these 6 cases. If we analyze these 6 cases, we will get that we can find a square congruence to 1 mod 3, okay, a square congruence to 1 mod 3, and a square congruence to 1 mod 5, okay, or a square congruence to what is plus 4 mod 5, but 4 can be written as minus 1 mod 5. If we will combine all these things, we will get a to the power 4 congruence to 1 mod 3, and what we will get, a to the power 4 congruence to, if we will square both sides, it will be a to the power 4, it will be 1, and this will be a to the power 4, and minus 1 square will also 1, so it gives s to the power 4 congruence to 1 mod 5. Okay, but we also know that let us give it equation 1. Also we know that a to the power 4 congruence to 1 mod 4. We can prove it. Let us prove it, because a to the power 4, this implies that a to the power 4 minus 1 congruence to 0 mod 4, means we have to check that 4 divides a to the power 4 minus 1. This is true, because a to the power 4 minus 1 can be written as s square minus 1 into s square plus 1. Okay, and a square minus 1 can be written as a minus 1, a plus 1, a square plus 1. We can verify that always 4 is a factor of this product. Let us take a is a even number. If a is a even number, then a minus 1 is also a even and a plus 1 is also even. So we can get the 4 from these two product. Okay, if a is odd number, then a plus not my previous explanation is wrong. If wait, if a is a even number, sorry, we cannot take a equal to in this question. Actually we cannot take a is a even number, because in the initial from the question given that GCD of a comma 30 is equal to 1. If a is a even number, then the GCD should be at least equal to 2, because 30 is a even number. If a is a even number, then GCD cannot be 1, so we cannot take a is a even number. So a must be a odd number. Okay, if a is a odd number, then a minus 1 is even, a plus 1 is even. From this we will get from a minus 1 we will get a factor of 2, and from a plus 1 we will also get a factor of 2, so we will get a factor of 4. Okay, factor of 4 means it is this number congruent to 0 mod 4. Okay, this is the from means this is an equation 2. From equation 1 and from equation 2 we get a to the power 4 congruent to 1 mod 3, a to the power 4 congruent to 1 mod 5, and a to the power 4 congruent to 1 mod 4. Okay, and these 3, 5 and 4 are relatively prime, so we can combine these things like this. This implies that a to the power 4 congruent to 1 mod 60. Okay, this implies that a to the power 4 minus 1 congruent to 0 mod 60, and minus 1 can be written as a to the power 4 plus 59 congruent to 0 mod 60. Okay, and this implies that 60 divides a to the power 4 plus 59. So the required answer is 60. So in our question, so the required answer is option A. Option A is true. Okay, option A is true. Let us move to the question number 11. In the question number 11, a homomorphism of a group into itself is called what? This is a standard definition from the group theory. A homomorphism of a group G into itself is called the endomorphism. So option B is true. Okay, let us move to the question number 12. The product of any 4 consecutive integers is divisible by 22, 24, 25 or 26. Let us verify the options. Product of 4 consecutive integers look like that: n plus 1, okay, n plus 2 into n plus 3. If we will look this pattern, suppose n is even. If n is even, this is even, means it is divisible by 2. Then n plus 1 is odd, it is not divisible by 2, but n plus 2 is even, it is divisible by 2. Here is also 2 factor, here is also 2 factor, means 2 to 4. At least we get the factor, that number should have factor 4 at least. Okay, let us verify the options. In 22 there is only factor 2. 22 can be written as 11 into 2. But here only factor is 2 but not 4, so this cannot be true. In 25 there is no factor for 4. Okay, and in 26 there is only factor for 2. It is can be written as 13 into 2 only, it is not 4. Okay, this 26 also not true, but 24 has factor 4. This is the only choice. Okay, so answer is 24. And you can also prove it by the modular form in the previous question number 10. Like this way you can prove that any 4 consecutive integers is divisible by 24. This is a standard question, one can prove it. Okay, let us move to the question number 13. In question number 13, given that S and T are subsets of a vector space V, and if S is subset of T, S is subset of T is given that we have to prove that LS, LT, LS means the linear span of S and LT the linear span of T. What is the relation? It is a standard theorem in the vector space. Okay, if S is a subset of T, then LS is a subset of LT, but means linear span of S is a subset of linear span of T. Here option A is true. Let us prove it. Okay. In the question it is given that S is a subset of T. To prove, what we have to prove? To prove L of S is a subset of L of T. Okay, proof. Let X is an arbitrary element which is a line L of S. This implies that X can be written as finite linear combinations, I from 1 to n alpha I Si. Okay. But we know that we know that we know what S is a subset of T. This implies that I from 1 to n, I from 1 to n, these elements belongs to S, which is a subset of T, means the Si elements I from 1 to n and 1 to n belongs to T also. This implies that alpha I Si summation I from 1 to n belongs to L of T. This implies that X also belongs to L of T. So so what will we get? We get that X belongs to L of S implies X belongs to L of T. This implies that L of S is a subset of L of T. This is a simple proof. You can prove it easily. Okay. So option A is the correct answer. Okay. So in this question, option A is the only correct answer. L of S is subset of L of T. Let us move to the question number 14. In question number 14, it is given that W is a proper subset of a finite dimensional vector space V. Then W is finite dimension, no doubt W is finite dimension, because V bigger space is finite dimensional, means implies that a smaller space means its subspace is also finite dimensional. And what? It is given that proper subspace means the dimension of W should be strictly less than the dimension of V. Okay. So the correct answer is dimension of W should be strictly less than dimension of B. So the correct option is B. Okay. It is no doubt. It is a simple question. So option B is true. Let us move to the question number 15. Given that V is a vector space of all 2 cross 2 matrices over the field F, then the dimension of V is, okay, dimension. What is the meaning of dimension? Dimension is the total number of the linearly independent set in that space. But for the space of matrices, 2 cross 2 matrices, we know that the standard basis means that linearly independent vectors can be generated by this type of matrices: 1 0 0 0, this one, and 0 1 0 0, okay, this one, and 0 0 1 0, this one, and last one is the 0 0 0 1. These 4 matrices can generate the any matrix. Okay, you can take the linear combination of these 4 matrices, then you can generate any matrix. So there is total 4 number of linearly independent matrices in the 2 cross 2 matrices. So the answer is B. Okay. Let us move to the question number 16. In the question number 16, T is a mapping from V4 to V3 is a linear transformation which is defined in this way. Then its rank. What is its rank? Let us calculate the rank of this matrix. Okay. Here in this question, what is asked? It is asked about the rank of this linear transformation. But what is the meaning of rank? Rank is the dimension of the range space. But here in the range space V3 is there. Okay. Let me write here in the codomain set is V3. So the range can be highest V3, dimension of V3. It cannot exceed V3. So the option means its dimension cannot exceed 3. So the option C and D cannot be true. Maybe either option A or B is true. Let us verify whether option A is true or whether B is true. Okay. In the question T, what is T? In the question T is a mapping from V4 to V3 and it is defined T of x1, x2, x3, x4 is defined in this way that x1 minus x4 x2 plus x3 x3 minus x4. It is defined in this way. It can be written as x1 0 0 plus 0 x2 0 plus minus x4 0 minus x4 plus 0 x3 if we will take common, then it can be written as x1 1 0 0, okay, plus x2 times 0 1 0 plus x4 times minus 1 0 minus 1 plus x3 times 0 1 1. Okay, if we look at closely that there are already two standard coordinate basis. One is 1 0 0 0, another is 0 1 0. So its dimension is at least 2. But by using these two standard vectors, we cannot generate these vectors because here the third element is non-zero. But in these two coordinates, here third element is 0. So we need at least one element. Either you can take this vector or this vector to complete the dimension of the range space. So the dimension of the range space should be 3. It should contain these two vectors, but you have to take at least one from this because the 3-dimension vectors dimension cannot be 4. You have to take at least one, not the both. Okay, so the dimension of the range space is 3. Okay, so the required answer is 3. So option B is true. What is the true answer? Option B is the true answer. Okay, option A is false. Okay, let us move to the question number 17. In question number 17, it is given that T is a mapping from U to V is a linear map and U is a finite dimensional. So what can we say about the dimension of U equal to dimension of RT? Dimension of RT means the dimension of the range space. Dimension of U is the dimension of the domain space. And in the option B, dimension of U strict less than dimension of RT, dimension of RT strict less than dimension of U, dimension, and in the option D, dimension of RT less than equal dimension of U. Okay, if you look closely that, then you will find that option A, if you look closely that you will find that option A, this option C, option A and option C are included in option D. So option D is the more correct answer. Okay, but option we have to check whether option B true or option D true. Okay, because when dimension of RT is less than equal to dimension of U, it implies the dimension of U may be dimension of R equal to dimension of RT, or dimension of RT should less than dimension of U. So if you compare option A and option A comma C with the option D, then we will find that option D is the more appropriate answer. Okay, but we have to check whether we have to check between the B or D. Okay, but from the rank nullity theorem, we know that dimension of RT plus what is the rank nullity theorem? Dimension of RT plus dimension of NT, null space, equal to dimension of U. So in this implies that dimension of RT, these are all non-negative quantity dimensions things are. Okay, non-zero quantity, non-zero and maybe 0, but non-negative quantity. So dimension of RT less than equal to dimension of U. Okay, dimension of U is a bigger quantity. So the option D is true. Option B is not true. Option D is true. Correct answer. Okay. Let us move to the question number 8. The nullity of the matrix is, okay, this we have to find the nullity of this matrix. Let us find it. Nullity means the dimension of the null space, and null space is defined if A is a matrix, then the null space is defined the set of all elements X such that X equal to 0 vector. This is the null space. If we find the dimension of this null space, then it is called the nullity of the matrix A. Let us find it. In the question, A matrix is given 1 minus 1 2 3 minus 2 5. Okay, this is the matrix. This matrix is what cross what? It is matrix is 2 cross 3, 2 rows 3 columns. This matrix can be treated as a linear transformation from what? From V3 to V2. Okay. By the previous question number, what was the question number? That was the question number 17. We know that from rank nullity theorem, rank of A plus nullity of A equal to dimension of the domain space, means dimension of V3. Okay, mean dimension of what is the dimension of V3 is equal to 3. So we get the rank plus nullity equal to 3. Okay. But from this given matrix, it is clear that the two vectors, this row 1 minus 1 2 and 3 minus 2 5, one cannot be generated by the scalar multiple of the other. So these two vectors are linearly independent. So the rank of A equal to 2. Okay, rank of A equal to 2. So the nullity will be what? Then the nullity will be NuLL. Nullity would be 3 minus 2 equal to 1. So the nullity is 1. 1 is the right answer. So the option B is true. Okay, what is the answer? Option B is true. Nullity is 1. Let us move to the question number 19. In the question number 19, the eigenvalue of the matrix are, what are the eigenvalues of the matrix? This is a simple question because it is a lower triangular matrix. In the lower triangular matrix, the eigenvalues are the diagonal elements. Here 1 1 0 are the eigenvalues. Okay, so the correct option is in the diagonal elements. Here 1 is this is also 1 and this is the 0. So the correct option is option D. Let us move to the question number 20. In the question number 20, if A is a M cross N matrix and B is a N cross P matrix, then AB transpose is AB whole transpose is what? This is a standard result that AB transpose, this question is asked usually in plus 2 level question. This is equal to V transpose A transpose. Okay. So the correct answer is option B. I hope today we will cover all the questions which were asked from the abstract algebra. Next time we will cover the questions from the analysis, real analysis or topology. Okay, bye bye. See you next time. Thank you all.